This video will explain how to automatically calculate distance reach settings using the Protection Coordination Assistant. In order to successfully follow these instructions, please make sure that the study case protection is first activated. The network we are dealing with has a system voltage of 400 kV and every line is protected by two distance protection devices. In order to see the relay locations, go to the coloring mode and choose the option Secondary Equipment, Relays. The devices are already configured and the zone reach settings are calculated according to the cumulative method. In order to execute the Coordination Assistant, it is not required to have fully operational devices implemented, or even any devices as we will now see. The Coordination Assistant tool is located on the Protection and Arc Flash Analysis toolbar. Please make sure that this toolbar is selected and open the Assistant. First we can choose the area where the settings are being calculated. For this example we choose the Northeastern Zone. In the second step, the user has the option to choose between settings calculated based on the network topology or based on already installed devices. When selecting the first option, the assistant will determine the settings for every circuit breaker. We will select the second option since there are already relays implemented. Under the page distance protection settings we configure the reach settings calculation method. There are three different methods which are all described in the user manual. To jump quickly to the manual press F1. Since the original settings are calculated using the cumulative method, we will also use this method for calculating the zone's reactance with a factor of 85%. For the resistive reach we will multiply a specified fault resistance by a factor. The factor is specified differently for phase and phase ground zones. The relay timer settings will be applied directly as specified. Under the Advanced Options page the user is able to configure the impedance selection for calculating Zone 3 and whether the switch status should be taken into account. After executing the assistant, a table report detailing the calculated settings is shown. In the first two columns the node and branch of the implemented relay is shown, followed by the reach settings and the time. You can see that the time settings clearly follow the rules set in the assistant. Their zone settings are calculated for three main zones and an overreach zone. The reach settings are displayed in order of increasing reach. If you would like to verify the results you can calculate the reach settings manually according to the equations found in the user manual. To evaluate the calculated settings graphically we can create a time-distance diagram of a defined path. In this example there is already a simple path defined which you can see by changing the diagram coloring to groupings, paths. This path includes four devices for which we calculated the reach settings. Access the Protection Coordination Report tool from the toolbar and activate the second option. Press Execute after choosing the path coordination. The time-distance diagram shows the coordination results. Every line is protected by Zone 1 to 85% of their length and the second and third zones are selective. By double-clicking on a zone you see the results belonging to the associated relay. Of course once network effects such as in-feeds are taken into account the actual reach of the relay could look different. Let us calculate a three-phase short circuit along this path. Double-click on the diagram and change the method to short circuit sweep. The short circuit command is already set to IEC method and three-phase fault so we can simply execute the command. The diagram changes due to the additional effects taken into account by the short circuit calculation. The reaches of Zone 2 and 3 decrease due to an intermediate in-feed and the starter times are displayed. If the zone reaches calculated by the Coordination Assistant are satisfactory, the user can write the results automatically into the protection devices. It is recommended to record the new settings in an active variation, thereby facilitating reversion back to the original settings if necessary.